Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing the truth table, characteristic table and excitation table for the JK flip-flop. So my students, in the previous lecture, we had introduced the JK flip-flop. It is a modification of an SR flip-flop in order to accompany or in order to implement the condition of clock is equal to 1, S is equal to 1, R is equal to 1, that is 1, 1, 1 condition. So in the case of a JK flip-flop, we can see that the condition of 1, 1 results in an output of Qn complement, and here also we can see that the output is continuously flipping, and that condition is known as a race around condition, and that race around condition will be discussed in the upcoming lecture. So my dear students, in this lecture we are creating the truth table, characteristic table as well as the excitation table for the JK flip-flop. So my dear students, if we are analyzing the truth table of JK flip-flop, if the clock is equal to 0, then whatever be the input of J and K, the output will be Qn, that is previous state. Here in the truth table, Qn represents the previous state and Qn plus 1 represents the current state. So 0 clock results in an output of preserving the previous output, that is we are dealing with a memory condition. If the clock is equal to 1 and J is equal to 0 and K is equal to 0, also results in an output of memory condition. And if the clock is 1 and J is 0, K is 1, results in an output of 0. If clock is 1, J is 1 and K is 0, results in an output of 1. And in the case of clock 1, J1 and K1, it will result in an output of Qn complement. So my dear students, now we are moving towards the characteristic table. So this characteristic table is formed with the help of a truth table. The inputs of characteristic table are Qn, J and K, and the output is Qn plus 1, that is the output is the present state, and this output is completely depending upon the previous state J and K. So now we are discussing what are the different possibilities of this characteristic table. So since we are dealing with the 3 inputs, the different combinations are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. So firstly, if we are analyzing the truth table with J is equal to 0 and K is equal to 0, then we can see that the output of 0, 0 condition is Qn. Here, in this case, that is, in the characteristic table, the first condition, J is equal to 0, K is equal to 0, here the output is depending upon the Qn, and here the Qn value is 0, and thus the Qn plus 1 value is also 0. So if you are moving to the 0, 1 condition, from the truth table it is evident that the output is 0. Thus, the characteristic value of J is equal to 0 and K is equal to 1 is 0. And if we are moving towards 1, 0 condition, the output is 1, and thus the output will be 1 here. And if we are moving to the 1, 1 condition, in the truth table, the 1, 1 condition results in an output of Qn complement. Here, in the characteristic table, the Qn value is 0, thus the Qn complement is 0 complement, that is 1. If we are moving towards the 0, 0 condition, it is a Qn value itself, that is, here we are dealing with a Qn of 1, and thus the output will be 1. And if we are moving towards the 0, 1 condition, the output will be 0 based upon the truth table, and thus the output will be 0 here. And if we are moving towards the 1, 0 condition, then the output is 1, and thus this 1 value is feeding towards the characteristic value. And finally, if we are moving towards the J is equal to 1, K is equal to 1 condition, the output will be Qn complement. Here in the characteristic table, the Qn value is 1, and thus the 1 complement will be 0. So my dear students, this is the characteristic table of JK flip-flop. So if we are analyzing this characteristic table is completely depending upon the truth table of JK flip-flop. So my dear students, now we are moving towards the excitation table. So this excitation table are used in order to create the counters as well as conversion of different flip-flops. Thus, the output of all excitation table will be the input value of that particular flip-flop. That is, here we are dealing with a JK flip-flop, thus the output of JK flip-flop's excitation table will be J and K, and the input will be present state and the previous state. Thus, the inputs are Qn and Qn plus 1, so the different combinations are 0, 0, 0, 1, 1, 0 and 1, 1, and this excitation table is formed with the help of a characteristic table. So now, if we are moving towards the different values, firstly we are dealing with Qn is equal to 0 and Qn plus 1 is equal to 0. If we are analyzing the characteristic table, we can see two different combinations, that is Qn equal to 0 and Qn plus 1 is equal to 0, have two different values. If we are analyzing those values, the J value is 0 in both these cases. Thus, the excitation table has the value J is equal to 0. And if you are analyzing the K value is either 0 or 1. Thus, we can tell that this K value is don't care in this condition. That is, either it is 0 or 1, then we can create a Qn and Qn plus 1 equal to 0 condition. Thus, the K value is a don't care condition. So, if you are moving towards the second condition, that is Qn is equal to 0 and Qn plus 1 is equal to 1, here also we can see two different cases. In this case, the J value is 1 in both these conditions, and the K value is 0 to 1, and thus we can tell that the J value is 1 and K value is a don't care condition. So if we are moving towards the third condition, that is Qn is equal to 1 and Qn plus 1 is equal to 0, here we can see two different cases with the J value is 0 and 1, as well as K value is 1 in both these cases. Thus, the excitation table values will be J is having a don't care condition and K is having a condition of 1. And finally, if we are moving towards the 1, 1 condition, here also we can see two different combinations with the J value as 0 and 1 and K value as 0 itself. Thus, we can tell that the excitation table has the J value don't care and K value is 0. So my dear students, this is how we are creating the truth table, characteristic table and excitation table of this JK flip-flop. So my dear students, as we mentioned, this characteristic table is completely depending upon the truth table and excitation table is completely dependent upon the characteristic table. So the truth table is an important factor in any of the flip-flop. So if we are dealing with SR, D, JK or T flip-flop, the characteristic table is formed with the help of a truth table and the excitation table is formed with the characteristic table. Thus, the truth table as well as the circuit diagram of any of the flip-flop is important. So my dear students, hope you had understood this topic. So my dear students, kindly write down this assignment question. Our question is, write notes on the characteristic as well as the excitation table of JK flip-flop. So dear students, see you soon. In the upcoming lecture, we will discuss the race around condition of this JK flip-flop and what are the combinations or what are the corrections that should be made in a circuit in order to overcome this race around condition. So dear students, see you soon. Until then, goodbye. Thank you and all the best.